What if the most livable place in our solar system wasn't Mars, wasn't the Moon, but the scorching, cloud-wrapped skies of Venus, our nearest neighbor, hiding a secret 50 kilometers above its hellish surface? For centuries, Venus was the planet of mystery and romance, glittering in the pre-dawn sky, close enough to seem familiar, yet utterly alien in every way that matters. It is the brightest natural object in our night sky after the Moon, so radiant that it casts shadows on Earth in the deep dark of a clear night. But beneath that dazzling beauty lies something terrifying. The surface of Venus is a pressure cooker, a planetary furnace running at temperatures of 465 degrees Celsius, hot enough to melt lead, hot enough to cook a pizza in 7 seconds, hot enough to make the dark side of Mercury, the planet closest to the Sun, feel mild by comparison. The atmospheric pressure on the Venusian surface is 90 times that of Earth, equivalent to being submerged nearly a kilometer beneath the ocean. Every Soviet lander that humanity ever managed to set down on that surface lasted no more than 2 hours before being crushed and incinerated. Venus, it seemed, was a dead end, a cautionary tale written in sulfuric acid and volcanic fire. But science has a remarkable habit of overturning the obvious. High above that molten, suffocating surface, something extraordinary happens. Rising through the thick Venusian atmosphere, somewhere between 48 and 60 kilometers altitude, the pressure drops to something close to Earth at sea level. The temperature settles into a range between 0 and 50 degrees Celsius, comfortable enough for human skin. Carbon dioxide still dominates, which means humans could not breathe unassisted, but the conditions become, by the violent standards of our solar system, almost gentle. This zone, this improbable ribbon of relative calm suspended above a planetary inferno, is what NASA scientists began calling, with understated scientific excitement, the Venus Atmospheric Habitable Zone. And it changed everything. The idea of floating human habitats above Venus was not born in science fiction. It was born in a 1971 paper by Soviet scientist Sergei Jitnik and later developed seriously by Jeffrey Landis, a NASA scientist and science fiction author, who in 2003 published a landmark study proposing that crewed missions to Venus should not land at all but instead float. His reasoning was meticulous and startling. A breathable mixture of oxygen and nitrogen is less dense than the carbon dioxide atmosphere of Venus at that altitude, meaning that an enclosed habitat filled with Earth-normal air would naturally float like a bubble in water without needing any active lift mechanism. The habitat itself would be its own balloon. A city in the Venusian clouds would not need rockets or rotors to stay aloft. It would simply drift, suspended by the physics of buoyancy, above the most hostile surface in the inner solar system. NASA's own high-altitude Venus operational concept, known as HAVOC, took Landis's foundational thinking and built it into a formal mission architecture. The HAVOC concept envisions crewed airships roughly 130 meters long, longer than a football field, floating through the Venusian upper atmosphere for 30-day missions, gathering data, conducting experiments, and laying the groundwork for something far more ambitious, permanently crewed cloud stations. These structures would face Venus's ferocious winds, which rip around the planet at 360 kilometers per hour at cloud altitude, circling the entire globe in just for Earth days, but engineers propose using those same winds for propulsion and power generation. Solar panels stretched across the upper surfaces of the habitats would capture energy from a sun that shines roughly twice as intensely at Venus as it does at Earth. The planet that kills everything on its surface offers remarkable solar energy in its skies. The clouds themselves, however, remain one of the most tantalizing and unsettling scientific puzzles of the modern age. Venus's cloud layers are composed primarily of sulfuric acid droplets, a detail that sounds purely lethal until researchers began studying them with new eyes. In 2020, astronomer Jane Greaves and her international team announced the detection of phosphine gas in the Venusian clouds. On Earth, phosphine is produced almost exclusively by biological organisms or by industrial processes that Venus obviously lacks. The announcement exploded across the scientific world, launching fierce debate, follow-up studies, instrument recalibrations, and extraordinary scrutiny. The phosphine signal was contested, revised downward, and challenged repeatedly, but the question it raised never fully closed. Could something be alive up there, drifting through sulfuric acid clouds, metabolizing and surviving in conditions that no known Earth organism could tolerate for even a moment? The clouds of Venus became, almost overnight, one of the most provocative frontiers in astrobiology. Scientists at MIT and elsewhere began modeling what Venusian life might look like if it existed. The hypothetical organisms, sometimes called aerial plankton, would need to be encased in protective coatings against the acid, perhaps wrapped in zero-water biochemistry fundamentally unlike anything terrestrial. Some researchers proposed that the mysterious dark streaks in Venus's ultraviolet cloud images, absorbers of solar energy that no known chemical compound fully explains, could be biological in origin, entire layers of microbial life filtering sunlight like a planetary skin. Nothing has been proven. Nothing has been confirmed. But the door has never been convincingly closed either, and the prospect of cloud life on Venus now drives serious mission proposals across space agencies on multiple continents. The Soviet Venera program, one of the most audacious deep space campaigns in history, sent 14 successful probes to Venus between 1970 and 1985, returning color photographs of a rocky orange landscape strewn with angular slabs under a dim, rust-tinted sky. Those images lasted mere minutes before the cameras went dark forever, destroyed by the environment. ESA's Venus Express orbited the planet from 2006 to 2014, revealing active volcanic hotspots, lightning storms driven by sulfuric acid, and a south polar vortex that churns and shifts in complex, almost organic-looking patterns. JEXA's Akatsuki probe arrived in Venus orbit in 2015 after a dramatic 5-year DT caused by a failed engine burn, and it continues today, mapping weather patterns in extraordinary detail, tracing the same screaming winds that would someday carry human habitats around a world where a day lasts longer than a year. In the early 2030s, NASA's Da Vinci mission will plunge a probe through the Venusian atmosphere, sampling the chemistry at every altitude on the way down, while the Veritas orbiter will map the surface with radar eyes sharp enough to settle the question of whether volcanoes are erupting there right now. ESA's Envision mission will add its own orbital perspective to the growing portrait of a planet being rediscovered in real time. These are not farewell missions. They are reconnaissance, the deliberate, careful surveying of a place where humanity might one day hang its future in the clouds. Venus and Earth are sisters by formation, born from the same swirling disk of gas and dust around the young Sun, nearly identical in size, mass, and composition. Yet they diverged catastrophically, separated by an evolutionary fork that scientists are still working to understand. Some models suggest Venus once had liquid water oceans for billions of years before a runaway greenhouse effect, possibly triggered by volcanism, stripped them away and transformed paradise into purgatory. If that is true, then Venus is not just a neighbor. It is a mirror, a forecast, a warning carried on solar wind about what greenhouse gases can ultimately do to a world. The urgency of understanding Venus is not merely scientific curiosity or the adventure of exploration. It is, in the deepest sense, the study of our own possible futures. And so the cloud cities remain, for now, a dream rendered in aeronautical engineering and speculative architecture, designs sketched in laboratories where scientists speak of tensile fabrics, automated solar farms, and pressurized habitation decks swaying gently in 400-kilometer winds above a planet no human foot has ever touched. But dreams in science have a way of becoming timelines, and timelines have a way of becoming missions. Somewhere above that golden, sulfurous inferno, in a band of air where the pressure is right and the sun burns bright and the temperature hovers at the edge of livable, there exists a zone that the universe seems almost to have left open, deliberately, patiently, as if waiting for a species curious enough and brave enough to rise into it and call it home.